So, product rule, right? U, V. Formula is y dash, which equals to u dash v plus v dash u. The derivative of x, which is u, is just 1. We agree with that? Times v, times square root x squared take away 9. Make sense? Plus v dash. Now to differentiate v, you know no surds allowed, no x's in the denominator. So this has a surd, it's not allowed. Change it to the power of a half. And then of course, once it's like this, what do we use? How do we differentiate this?
You take up to x and bring the half down.
Yeah, so it's called starts with C, chain rule. Yep. Half, open bracket, x squared take away 9, subtract 1 from the power, and then multiply by the derivative of the inside, which is 2x. And then of course, half times 2 cancels out. And you end up with something like this. X squared take away 9 plus, can we tell the x will be in our numerator, but a negative half goes in the denominator. So negative indices go in the denominator. Are we used to that by now? Negative indices, denominator. So x stays on top over what? What would you say, Natalia?
Negative.
But the negative is going to become positive in the denominator, right? So this whole thing is going to become... Yeah, so...
You haven't finished that, you haven't put the u in. Now it's v dash u.
That was v dash, correct. V dash times, my bad, times u. U is x. I did it before, I forgot about it now. So let me highlight that. So this whole thing is v dash. That is the whole derivative of this line here. Just look at it again. Bring the half down, leave the bracket, take away 1 from the power, times the derivative of the inside, 2x. And then times v dash times u. U is x. Make sense? So that should be x squared. And then over x squared minus 9 to the power of positive half. Do you get that? It's really important, that one there. X to the power of negative 2. How could you write that as a positive index? 1 on x to the power of positive 2. Yeah. Remember these negative index laws? Yeah, but it's super important for calculus. So negative half, positive half, and then of course again, a positive half, what does that become? Square root again. So equals x squared minus 9 plus x squared on square root x squared minus 9. You're not done. If you want to be competing, like I keep telling you guys, with the extension kids, they'll do something else to this. What do we usually do when we've got 2 fractions? Make them 1 fraction. You've got used to that by now. Make it 1 fraction. So you've got to have a common denominator. What's your common denominator? Root x squared minus 9. Obviously, what's root x squared minus 9 multiplied by root x squared minus 9? Well, the square roots cancel out. You get x squared minus 9. And we are literally 1 line away. Equals 2x squared minus 9 over square root x squared minus 9. That is the final mark. That's the final answer. The question would be worth 3 marks. 100% in your exams. 100%, exactly this one. Instead of it being x squared minus 9, they might use x squared minus 10. But it's essentially this, because they know that a lot of students will not move from this line to this line. Yeah, I'm telling you. So we know that, so therefore we just keep asking the same thing over and over again. I'm telling you guys what's going to be in all your exams, different schools, and it's going to be exactly this. So get used to it, because once you get it back, and I'll just tell you, I told you so. Next one. Let's do a trig ratio one. Let's see how we do with this one. Copy to clipboard, go back, Please stop me if we have questions. If I'm going too fast. Go ahead. Find all values of theta such that theta is now between 0 and 720 degrees. The only students that would be able to get this right are those who have done it my way. For those who have followed the teachers, unfortunately, you probably won't be able to execute it fully, but we'll see. For which sine theta is equal to negative 0.927, we want it to the nearest degree. The only clue I would like to give before I get you guys started on this, you're solving for theta. Right, Tiana? Solving for theta. The only clue I'm going to give you is do not include the negative when you're shift signing. And then you have to obviously do you have to do that, and that's what the negative's there for. So go try that. Just try and see what you can get out of it. That's it. Don't inverse the negative, and you obviously will use all stations central, where is sine negative. See if you can get it out from there.
Then the second quadrant?
No, that's where sine is positive. Yeah, but you haven't done this with me, so it's okay. I get it. Don't worry. What would you usually do? Don't know. Yeah, all good. Okay. Anyone want to give it a shot to see if they've got it out? You guys not? Maybe Lassandra's looking like he's writing something down. Maybe he's just writing his name down. Who knows?
I've got the decimal answers. Is that fine?
Well, it says nearest degree,
Okay.
which is fine, but you got to write it to nearest degree. All right, tell us what your first step is. So theta with hats is the way I do it.
I got 67.97.
So you did this,
Correct.
and then you got 69. No.
Yeah.
69.
67.9.
Sorry, 67.9. Yep.
Yeah.
And then at this stage you stop.
Yeah.
What do we draw?
The all stations to central.
You stop. You draw all stations to central. Then you ask yourself.
Where is sine negative?
Which is?
T and C.
T and C. Sine is negative here and here. Because T and C sine's negative. So therefore your answer, your actual theta is? This is
plus
180 plus theta, and this is 360 minus theta. Yep. So 180 plus, let's just do 68 degrees. 68 degrees and
248.
360 take away 68. Perfect. So then you got 248 and
292, let's say.
And that's it?
Yeah.
Cool.
And don't we have to do the extra thing that you taught us before?
Put them into radians?
No, you don't need to because it says nearest degree. So that's fine.
Plus 360 and you did.
Good, see? So you were there. All right. I don't know if you guys heard, but Natalia just said you've got to do that plus 360 business. And the reason being, the domain is going all the way up to 720. So remember, you have to remember something. I am allowed to take any angle. Let's just say if it was an angle that was here. I'm allowed to take that angle and add 360 and subtract 360 forever. All you're doing is you're making the angle larger, but the position is the same. So technically, if my domain here is larger, I should have more solutions as well, right? Because my domain's larger, that's all. So yes, you are meant to, at this stage, where am I? Right there, add 360 to both of these solutions. So what's 360 plus 248? 608, yep. And?
658.
And just so you guys see, like, I never said once. I said as 652. I said as many as you like, right? Remember, I said add and subtract as many 360s as you like. So add more. Add another 360 to 608. Well, that's going to get you 968, and that's when you realize, right, I'm outside of my domain, so stop. So it's good for you to learn, just add more or subtract. It's better than obviously missing answers. Any questions? Okay. You guys at home, any questions? All right. Okay, that's done. Yep, you can do this one, real functions. I'm just going to copy it here. Don't overthink it. Just assume it was your exam. You're going to write something down, right, Tiana? You can't say to yourself in your exam, I can't do it. So you'll just do whatever you can do. If h of x, so if a function is ax plus 1, if x is less than or equal to 1, and it is x squared minus 5 if x is greater than 1, and we know this result, find a. Good day. How are you? How do we go?
Okay.
You got that something? Yeah, I'm done. What'd you get for A? -5? No? No?
Oh,
A-
God.
Anyone got an answer?
Sam, would it be negative
Yes? Negative
Oh, wait,
One.
never mind.
1? Do you
Yeah,
agree with negative 1? No? Tiana's looking, she doesn't know.
Don't worry, I figured out where.
Are you sure?
Wait a second, let me check.
Wait, yeah, don't rush it.
Go.
Okay, well, Eden, tell us what you've done. What does h of -2 mean?
that's like because like the -2 is below 1, and so you use
Yes.
the formula next to it.
Do we agree with that? -2 is below 1, so it's this one here. So we're going to use the first one, which is ax plus 1. So ax plus 1. Tiana, did you do something like that? Then perfect. So you replace your x's for -2. The next one, it says a 4. And we know 4 is obviously where x is greater than 1. This one here. 4 squared. 4 squared minus 5. So 16 take away 5 is 11. I'm liking your answer, miss. Equals 10. A equals?
-5.
Why did you say that you felt like you did something wrong?
I thought I did, then I checked and I didn't get it wrong.
A equals -5. Eden, you must have done a mistake somewhere.
Yeah, I didn't substitute the -2 or the 4.
Okay. All right, fair enough. Yeah, you guys should know that by now, right? This is this is h of x. X is being replaced for -2 and 4 respectively. And plus, you're the one that said, -2 means it's here. So if it's in this region, then yeah, you gotta just obviously sub in -2.
Yeah.
All good. Good work.
Yeah.
Trust yourself. All right. Before I continue anymore here, I think I want to do, you said derivatives of exponentials.
Correct.
So let's do that. So just a bit of derivatives of exponentials. Just derivatives. Yeah, just that's it. Just derivative exponentials. Just deriving.
Yeah,
Like differential. Yeah. Okay. Yeah. Easy. Y equals. All right. So I don't know if you want to write a heading. Derivatives of exponentials. They work a little bit differently to Your normal ones. Well, you're not going to do derivatives of logs until next year, year 12.
This year in class.
Derivatives of logs?
Yeah.
Ellen, anyone else has done derivatives of logs?
I think we covered it in the
Yes?
Yeah.
Then my bad. Then we're going to do both. Derivatives of exponentials and logs. I thought it was next year. I'm obviously wrong. Derivatives of exponentials and logs, please. Thank you. Okay. We'll do logs first because they are actually easier. So logs. If I've got y is equal to ln x, it is very easy. Do you feel like you'll know how to teach it, Lissandro?
Yeah.
ln x? Yep. What would you say for y dash?
Y dash would be the derivative of the inside of the brackets over the original function.
Original of the inside. If you say function, you might think ln x.
Yeah.
So it's derivative of the inside over the inside. Easy? Yeah. So we'll do one more. Y equals log. What if I did x squared plus 5? What does y dash become? Natalia, you want to try it? Derivative of the inside over the inside.
2x.
On. Yeah. Maybe I'll write that now. So pretty much if you had anything, y equals f of x, sorry, y equals log f of x, anything, the derivative is f dash of x, differentiate over f of x. I was thinking of integration of logs. Yeah, derivative of logs is this here. Integration is going to be the hard one. To know that from here, without a log, you have to go into a log. That's hard. No, that's next year. Okay, so should we do one more? What's the hardest one I can think of?
One with chain root and
No,
we've done that before.
I was going to say, look, the harder one would be something like this.
What?
Quotient.
Yeah,
Yeah.
Oh God.
yeah, which isn't too bad if you realize it's quotient rule. U, V.
Yeah.
Tell me. Yeah, tell me. Eden, go.
Differentiate. Oh,
So-
wait. What? How is... Wait, to just make the same... Yeah, u dash v over v squared.
Right, and then how do I differentiate ln x? So now it says u dash, so what's the derivative of ln x? Correct. 1 over x. Differentiate the inside over the inside. Times v. Minus, what's v dash? Times u. What's u?
Our x.
Say again?
It would be x or ln x. Ln x.
It says, yeah, look, u. u is ln x.
Okay.
You can make it easier for yourself. You're making it harder. All over
X squared.
x squared. What happens to these two x's? And then your answer is 1 minus ln x on x squared. That would be what we say is harder. Why? Because a lot of students usually get stuck now. Wait, how do I do u dash? But the idea is it's still a log, so it doesn't really make a difference. You just, the harder bit of it would be you have to realize it's a quotient rule. Yes? Yep. Cool. Let's try another one. Let's try now y equals x squared ln x minus x squared. That's going to be fun. What are we going to do? Differentiate this. Why?
Because there's two different terms.
This is u, this is v. There's two different terms. There's your x squared, then there's your log. That's one whole thing together. Cool? Because log is together. It doesn't matter what the bracket is. It's a log. So that's one function, and then you get your x squared. That would be another function. All right, you have to use product rule. Again, product rule is u dash v plus v dash u. So y dash equals, go. Natalia, let's do it. U dash 2x and then v plus v dash. Now, the rule was differentiate the inside over the inside. So, what's the derivative of the inside?
Minus 2x.
Done. So you keep saying that, right? Derivative of the inside over the inside. 1 minus 2x over?
X minus x squared.
That's v dash. That's v dash. You agree with that? Times. Now you got u still.
X squared. But what do we do with the ln?
Which ln? Like this ln here?
So we don't put any ln in that.
No, the rule is this. Let's go up for a second. Look. Right here. ln does not become an ln.
Okay.
It becomes derivative of the inside over
The
inside. There's actually no logs, which is weird. I get it, but that's how that works. It's the only one that does that. Exponentials won't do that. Your trigs won't do that. Obviously, algebra doesn't do that. Logs do that. So it starts as a log. It does not end as a log. So have a look at that. Any questions? No? Everyone's good? All right, what would I do at this stage? I'm very worried about ever writing up times x squared when I can see two terms here. I'm worried that in my exam, I might forget to actually expand this whole thing properly. So what I did just then, I put brackets in. That's something that you have to learn from your own math. Like you got to know if there's two terms, you got to be very careful with your times x squared. Really, making this into a common denominator is not going to do anything because you're not going to be able to make it any simpler. So the final answer we're happy with is literally 2x log x minus x squared, x squared minus 2x cubed. No, I lied. Wrong. I'll say why now. You always want to cancel before expanding. The fact that the top is technically already factorized, can you guys see if I factorize the bottom, I can actually cancel this x with that x. Can we see that? But if I had expanded, it might have been a little bit harder for me to see. The common x's. That is the final answer we want. You can now expand it or you can leave it in factored form. It doesn't matter. So, do you see what I did there? Factorize the denominator. Why? Because the numerator, I can actually cancel out one of the x's. All right. Any other questions at this stage? No? You guys are happy? Okay. That's logs. Pretty much logs. Your chain rule, differentiation, product rule, sorry, quotient rule, rules still apply. The idea is it's just phase for logs now. And how do we differentiate logs? Differentiate the inside over the inside. If you've got to write that down, write it down. Differentiate logs, differentiate the inside over the inside. Okay. Let's do exponentials. Exponentials. Let's do it. We have y equals e to the 5x. Okay, this one you would write this sentence. Exponentials are always exponentials. Sounds simple enough, doesn't it? So, y equals e5x becomes, Alessandro, take a guess.
The exact same.
So take a guess.
E equals 5, e to the power of 5x.
Any questions? You're not done, but any questions? So that's easy to remember at least. So logs don't become logs. That's what I'm trying to emphasize. Logs, you got to tell yourself, differentiate the inside over the inside, full stop. E's, exponentials do become exponentials, so they become themselves. That's your first step. They have to become themselves. Then you just do one extra thing, which is super simple. You have to differentiate what component you reckon.
5x.
The
power.
5x. Yeah, the power. You just differentiate the power. So what's the derivative of 5x? And you just got to multiply by that. Done. So exponentials are always exponentials. Then differentiate. Obviously, the only thing that you have with x is the power. And that goes in the front.
Wait, so the power stays the same.
Yes. Yeah. That's why I said that. Exponentials are always exponentials. That's why that quote's there. I didn't say subtract 1. I didn't say we still did what we did last week. Well, no, it's new. Exponentials are exponentials. Done. You do not subtract 1. You do not bring the power down. Some people think like that. It's differentiate the power. And then you multiply by whatever that is. So we'll do another one. Y equals e x squared minus 2x. Tiana, shoot. Y dash. The first thing before I even think about anything else, what are you going to write?
2x minus 2.
Fair enough. I wasn't expecting that one. I was expecting the e bit, but that's even better. That's even better. 2x minus 2.
And then ax squared. And then you can rearrange it and make it look like. Really? Okay. That's what we get told.
Get told to do what?
We always make sure that the numbers are at the front.
Yeah, correct. But always your power's at the front.
Yeah.
Yeah. But what you said rearrange it.
Wait, don't worry.
Like usually you're saying we don't write it like this. Have you ever written x3?
Yeah.
No.
3x.
No, 3x.
Don't worry.
Yeah. That's what they're trying to say. So usually we want our numbers at the front if we can. So same with like surds. Very unlikely you're going to ever see me write x squared minus 9 x. We just don't do that. We do it as, where is it? X, square root x squared minus 9. Yeah? It just looks neater. Same thing with sine. We don't write sine theta 2. We write 2 sine theta. Cool? So, yeah. Like you're saying, I got taught that. You're kind of isolating it for this topic. I'm trying to say, no, you should be doing that naturally anyways. Forget that it's this topic. Cool?
Yeah.
Done. Easy? Does that solve your problem, Sandra? You said differentiating exponentials.
Yeah.
Simple. Exponentials are always exponentials. The only thing you got to remember, differentiate the power. So let's make it fun. Yes.
Examples of,
Sorry?
do you have an example of it having the chain rule or the product
Yeah,
rule?
you can do anything though, right? I can make it into a chain rule. I was going to introduce logs with this one, so let's do that. Y equals e 3 ln. Well, let's do basic one. Hold on. E, yeah, one step at a time, right? E log open bracket x squared. Now, some of you might know the answer maybe straight away. Anyone have something that they realize with an e and a log?
Just cancel.
Right? So if you see a question like this, straight away you could do it the easy way, which would be, oh, they cancel out. So I'm actually just differentiating what? And then therefore your answer is just. Now, if you didn't realize that, what can you do? You got to do it the long way. So here we go. E log x squared, y dash equals, all right, exponentials are exponentials. So E log x squared. We agree with that?
Yeah.
Times derivative of the power. What's the derivative of log x squared?
2x on x squared.
Do we agree with that? 2x on x squared. Next line, square x cancels out. I have 2 on x, e log x squared. Now at this stage you needed to realize, oh yes, e and log still cancels out. So you can see you can't avoid that problem that I had at the beginning, multiplied by x squared, right? And then you square and this cancels out, you're left with 2x. So it's up to you. Both gives you the same answer. It's just, did you realize it? If you did, good. You didn't, oh well. And only an e and a log can cancel. If there was a 2 in front, there's 2. You can't use the 2. What do you have to do? Bring it back up to a power. Okay? Let's go up one more level. Chain rule. Y equals 3x minus 2e 2x plus ln 5x all to the power of 3.
You really went for it here.
That's it. If you can do this, then you can do anything. Right? Because it's got everything. I've got your algebra, I've got your exponential, I've got your log.
Oh my God.
Yeah, everything. That's it. So, Eden, you want to try it? Y dash.
Okay.
Maybe try it on your own first.
Yeah.
You have to first use the chain rule.
Yeah.
That's my clue. Drink up a drink of water. You guys want tea or coffee? Oreos? An Oreo?
No.
You look healthy. Maybe?
Maybe.
Let's have a look at yours. Looks good.
I got the first
Correct.
one. I think.
So, what is it?
I think I got the first line.
I think you got it out. It's not hard.
Yeah.
It really isn't. Yeah, the first line is technically the answer. So let's see. Go.
Uh,
An issue.
Yeah.
Essentially, Laplace isn't here.
Yeah.
So he wanted us to kind of call him and do the Zoom meeting as if, yeah. But I'm unable, and so Kiva need to send the actual work to him. Every email we send kind of gets kicked back
How come?
from Google.
All right, I'll be up in a sec. 3, yes. Go ahead.
me?
Yep.
Okay. 3 bracket 3 times negative 4e power 2x times 5 over 5x.
Plus 5 over 5x. Yep.
Oh, okay. Bracket, and then 3x minus 2e power 2x. Yes.
It's hard just saying it. All right, I got it. Yeah, I think you got it. I think that's right. So all she's done is she's brought the 3 down. We agree with that. She wrote the bracket again. Took away 1 from the power. Do we agree with all that? That's normal chain rule. Multiplied by what? Of derivative on the inside. So here we go. What's the derivative of 3x? 3. What's the derivative of 2e2x? Well, hold on. 2e2x is 2e2x. But then because you've got to differentiate the 2x, 2 times 2 becomes 4e2x. And then plus the derivative of log 5x is 5 over 5x, which eventually cancels out to 1 on x. And done. You wouldn't expand it because you'd just be silly. You're done. So it looks hard, but it's just the same thing. There's rules, right? Chain rule first, and then each one inside. I don't know. You won't really get that because it's just silly, but there you go. If you can do that, then that means you really understand what's happening. Okay, what else? Back to exams or? Let's do it.